Welcome back to the OpenClaw Bootcamp. I'm Adhiraj, and today is day 11. Your agent has channels, personality, memory, roles, tools, and skills. It can talk on WhatsApp, search the web, browse pages, run commands. You've got all the building blocks. But can it check your Gmail? Can it manage your Google Calendar? Can it react when someone pushes code to GitHub? Can it fire off tasks on a schedule without being asked? Today is about wiring those building blocks into real-world services. This is where your agent stops being a conversational tool and becomes embedded in your actual workflow. It's day 11. Let's get started. On day 10, you dug into the skills architecture, the difference between tools and skills, the core built-in tools that ship with every installation, Claw Hub for community skills, and building your own custom skill from scratch. Today, we're covering three things. First, the automation trigger architecture. So webhooks, cron configuration, and how they work alongside the heartbeat system you set up on day 6. Second, the productivity integrations that matter the most with the config details for each. And third, building custom integrations from quick conversational creation to the full 10-link enterprise chain that production deployments use. You've already connected the channels on day 5 and set up your heartbeat on day 6. Your agent can talk on WhatsApp, Telegram, Discord, and it can check in on a schedule. What you haven't done yet is configure the other two automation triggers, which are webhooks and cron, or connect the productivity tools that make your agent actually useful for real work. Webhooks let external services wake up your agent, like a GitHub push, a Stripe payment, a form submission that sends an HTTP post. Through those, your agent's going to react. Cron gives you the exact time scheduling, like daily at 8 a.m. or every Monday at noon. And Heartbeat, which you already know, fires on interval. These three automation triggers are how your agent works without being asked. The mental model here is channels are where your agent listens and speaks, triggers are what make it act on its own, and today we're going to wire up the triggers and the productivity integrations that make the whole system useful. Now let's break down the three automation triggers for their actual configuration, because the difference between them matters, and knowing when to use which saves you from building the wrong thing. Webhooks are event-driven. Something happens in the outside world, and then it sends an HTTP post to your agent's webhook endpoint. Configuration is straightforward, as you can see. Hooks enable turns it on. Hooks token is a secret key for authentication, so random requests can't trigger your agent. Hooks path sets the URL path. Your agent receives the webhook payload as context and responds accordingly. Cron is exact time scheduling. You define when something should happen using the standard cron syntax, like daily at 8 a.m., every Monday at noon, or first of the month. The configuration is cron enabled, cron.max concurrent runs to limit how many cron runs can execute simultaneously, and cron session retention for how many days to keep completed cron session data. Heartbeat is a periodic check-in system defined in the Heartbeat markdown file with heartbeat.every for the interval, heartbeat.target for where to send the output, and direct policy for delivery behavior. Unlike cron, which fires at exact times, Heartbeat fires on interval relative to when the agent started or last checked in. The rule of thumb here is use Heartbeat for recurring agent-initiated work, like morning briefings and monitoring. Use cron for exact time scheduling, like reports and backups. Use webhooks for reacting to external events like deploy notifications and payment alerts. If you're not sure, ask yourself whether the trigger comes from inside the agent, from the clock, or from the outside world. That's going to tell you which mechanism you should use. Google Workspace is probably the single highest impact integration for most people because email and calendar are where the real work lives. OpenClaw is going to handle this through the GOG skill, which has Gmail, Calendar, and Drive in one package. With Gmail, your agent can triage your inbox, draft responses, send emails, and manage labels. Calendar, it can check availability, create events, detect conflicts, and prepare meeting briefs. With Drive, it can create documents, search for files, and extract content. The setup uses OAuth, and the GOG skill handles the authorization flow automatically. First time you use it, your agent walks you through granting access. Tokens get stored securely and refresh as needed. There's no manual API key juggling here. But the key thing I need you to remember is always use a dedicated Gmail account for your agent. Never connect your personal Gmail. Your agent gets full read and write access to whatever account you connect. You can read every email, send as that address, modify your calendar. This is a security boundary that you do not want to blur. Create a separate Google account for the agent, forward what you wanted to see, and keep your personal account separate. This is a hard rule for anyone serious about running agents safely. Your agent needs access to the internet to answer questions about current events, research topics, and gather real-time information. OpenClaw supports a wide range of search backends, and the one you pick affects your costs, privacy, and reliability. The recommended option is SearchNG. It's self-hosted, which means zero API costs and no rate limits. You run it on your own infrastructure, and it aggregates results from multiple search engines, and you have full control. You can install it by following the command on the screen or configuring it manually in OpenClaw.json. Trade-off is you need to host it somewhere, but if you're running OpenClaw and Docker anyways, then adding this to your compose file is trivial. The simple alternative is Brave Search API. Just get an API key and configure it, but the trade-off is usage limits and per query costs, but the setup is minimal. It's a good starting point before you migrate over to SearchNG. But beyond those two, the list's extensive. So you can use DuckDuckGo for free no-key search, Exa for neural research queries, Tavily for AI-optimized results, Firecrawl for web scraping combined with search, and then the model integrated options like Perplexity, Gemini, Grok, Kimi, Minimax, and Ollama Web Search. You can configure your preferred backend in OpenClaw.json, or just tell your agent which one to use and it handles the configuration. My recommendation is start with Brave or DuckDuckGo to get search working immediately, then move to SearchNG when you're comfortable with Docker. Self-hosted search is better in every dimension, except for the initial setup effort. Web search gets you text results, but some things require actually browsing, like filling out forms, interacting with JavaScript-heavy web apps, taking screenshots, extracting data from rendered pages. That's where browser automation comes in. OpenClaw uses Playwright under the hood with Chromium. Your agent gets a full browser to control so it can navigate to URLs, click elements, fill up fields, take screenshots, and extract content from fully rendered pages. This is the tool for anything that simple HTTP requests can handle. Setup is super straightforward. So you install Chromium through Playwright. The agent uses a dedicated browser profile completely isolated from your personal browsing. So separate cookies, separate sessions. This is the same principle as the dedicated Gmail account. Never let your agent operate in your personal context. The security feature to know about is SSRF blocking. By default, the browser automation blocks access to private networks, so no browsing to localhost or internal IP ranges. This is super critical because prompt injection attacks could theoretically make your agent browse to internal services and exfiltrate data. The SSRF blocking prevents that by default. If you legitimately need your agent to access an internal service, say you have a local dashboard or an internal API, you could add specific host names to the hostname allow list, and this gives you controlled exceptions without disabling the protection entirely. Whitelist what you need and block everything else. Everything we've covered so far, like channels, webhooks, Google Workspace, search, and browser, these are pre-built configurations. But the real power is building your own, and OpenClaw gives you 3 paths, depending on how much structure you want. First path is building a skill from scratch. You create that skill markdown file with the instructions, find the parameters, and build the handler. This is what you learned on day 10, and gives you full control over every detail. Use it when you know exactly what you want, and the integration has specific requirements. Second path is a conversational shortcut. Do something manually with your agent, like walk it through an API call, show it a workflow, and then say turn what you just did into a skill. The agent's going to package the workflow into a reusable skill automatically. This is remarkably effective for straightforward integrations where the steps are super clear and easy to follow. The third path is guided teaching. So walk the agent through the integration step by step, explain it the API, the auth flow, the data format, and it learns and codifies the workflow. This is somewhere between the first two in terms of control and effort. For enterprise integrations, think in terms of a 10-link chain. Input receives data from any channel or trigger, context loads memory or preferences, security validates permissions and sanitizes the input, research gathers external data, extraction parses it and structures it, reasoning analyzes and decides, production generates the output, logic host executes business rules, verification validates before delivery, and analytics logs and measures results. Not every integration needs all 10 links, but knowing the full chain is going to help you design robust systems that handle all sorts of edge cases. 4 things before day 12. First, go ahead and set a web search, install SearchNG, or configure the Brave Search API with your key if you want faster setup. Test it by asking your agent a question about something that happened this week. If it searches the web to answer, your backend is working. Second, connect one productivity tool. Install the GOG skill and connect Gmail or Calendar using a dedicated Google account, not your personal one. Test it with something simple. So check my calendar for tomorrow or summarize my unread emails. Verify that the OAuth flow completes and your agent can actually read and act on the data. Third, create a webhook or cron automation. Set up a cron job that runs daily summary at a specific time, or configure a webhook endpoint and trigger it with a curl command. The goal is to see your agent activate without being asked, so it's automation and not just conversation. Fourth, go ahead and test out the browser automation. So install Chromium through Playwright and ask your agent to browse a real website like LinkedIn and ask it to take a screenshot or extract data from that page. Then test the security boundary and confirm that it refuses to visit localhost or internal IP addresses. Understanding what the agent can and can't browse is super essential before you put this thing into production. At this point, your agent can reach out, touch the real world, and react to it, but everything we've built so far is running on your local machine. It's fine for development, but it's not how you run an agent in production. Day 12 is Docker, so containerizing your agent for reproducible, isolated, production-ready deployment. If you want help building this out, consult with me at adirachungle.com, and if you want a community of people building and selling AI automations, join the free AI automation sprint. The link is in the bio. Subscribe, and I'll see you on day 12.